Eric is going to go first. Eric Smiley is he has a master's in science, and he's a professional engineer. Eric is the principal of Reid, Wylde Engineering Limited on Vancouver Island. This is a renewable energy engineering company. His past experience includes coordinating the Green Building and Renewable Energy Technology Diploma Program at Vancouver Island University and working as a project leader at the BCIT Photovoltaic Energy Applied Research Lab. Mr. Smiley also holds a master's degree in energy system modeling and is a field safety representative for solar photovoltaic in BC. He's registered as an electrical engineer in the province of BC and has 20 years of experience in residential and small commercial renewable energy system design, installation, and sales. Mr. Smiley continues to teach renewable energy and engineering courses for various organizations, including the Solar Energy Society of Alberta, NATE, BCIT, North Island College, Solar Energy International, and CanSIA. He's an associate of ASHRAE, a board member of the Energy Educators Network, former chair of the NABCEP Exam Committee for Photovoltaic Installers, and former member of the CSA Section 50 Subcommittee. Eric's also presently teaching here at NATE for the Alternative Energy Technology Program. Following Eric will be Gordon Howell. I think a lot of people know Gordon, as he spoke on many topics in the past. Gordon is a professional engineer. He's an electrical engineer working in the solar industry for 30 years. Gordon designs and develops grid-connected solar PV systems for houses, buildings, and industries. And in 1995, the solar PV system on his house, which was sponsored by Edmonton Power and Natural Resources Canada, was the first one connected to the grid west of Toronto. And he's the 12th one in Canada that was grid-connected. Gordon works with municipal, provincial, and federal governments, regulators, and electric utilities. And Gordon has made immense help in removing barriers to the adoption of solar photovoltaics in Alberta. And Gordon also has worked with the City of Edmonton to lead the Renewable Energy Task Force. Okay, so I'll welcome the two of them to tonight. And Eric, do you want to start off?
Thank you very much for inviting me. Not sure if I feel comfortable leaning in here like this. It was, as in the introduction, I've been working in this field for about 20 years. And tonight I'm going to just talk about one case study, which is this project that I've recently completed, I guess, the third phase of work on up in the Northwest Territories. Blatchford Lake Lodge is located on Blatchford Lake. It's about a half-hour flight from Yellowknife, about 80 kilometers east of Yellowknife. And I've been working with them for over 14 years now. So I think they make a really excellent example of what's going on in the north in terms of renewable energy, and it allows me to talk a little bit about what the opportunities and challenges are working up in the Northwest Territories, and what a wonderful place it is to work up there as well. Sorry about that. So Blatchford Lake Lodge is was built about 14 years ago. When I was working fresh out of university, I was working for a renewable energy company called Energy Alternatives, and we were approached to design the renewable energy system, the whole energy system for this lodge, which was under construction. And at the time, we were charging about $8 to $10 a watt for the solar modules at that time, and it was just too expensive for them, considering all the other construction costs, to do the solar components, so they put in a battery, inverter, and generator system, a cycle charging system at the time. And that operated for about 4 years, running the lodge, which was the only electrical load up there at the time. And then 4 years in, I had already left Energy Alternatives, so I was contacted again, and I flew up independently on behalf of the lodge owner, and we installed a very small solar array of 6 85-watt BP solar modules. And we also installed a 1 kilowatt wind turbine. That, at the time, offset about 15 to 20% of their electrical energy use. So it had an impact on their energy consumption, and they were quite pleased by it, but there was certainly plans to do a lot more. Subsequent to that, about 10 years in, the first set of batteries finally failed. These were the batteries that we'd installed when the lodge was being constructed. They finally had reached the end of their lifespan. And I wasn't available because I was teaching full-time at Vancouver Island University, and so a local contractor went up, and you can see the 6 solar modules. So those, he removed all the existing equipment except for the genset, which actually had been rebuilt, I think, at that point, and put in 6 new 185-watt solar modules, 2 new inverters, replacing the SW, old trace inverters with new Schneider Xantrex inverters and a new battery bank. So that was sort of the second, well, that I guess was effectively a third phase of the project. Unfortunately, the battery bank was drastically undersized, and the loads in the lodge had increased considerably. They were now running power to 5 guest cabins, and they had some accommodation for staff. And so they were having difficulties with operating the system because the batteries were only capable of lasting for about 4 hours before they had to turn the genset back on, which was very frustrating. So then finally I get another phone call, and now I'm no longer working at VIU, I'm working for myself again, and that's where the story picks up. So the challenge here, of course, is the remoteness. It's a fly-in only lodge, and it's a high-end lodge. They've got guests coming from all over the world to view the aurora. Some of them go fishing, but generally speaking, people are looking for a certain level of comfort, and so they have to cater to that. So for example, the remoteness means all equipment has to be flown in, which isn't unusual in the Northwest Territories. It means that the cost of their diesel up there, landed cost, was about $3 per liter, including shipping and handling costs. So when people ask me now, the price of fuel is coming down, how's that going to affect your business? I say, actually, it doesn't, because so much of the cost for many of these systems is the transportation and handling. It really doesn't affect the payback that much, whether it's $1.50 a liter or $1 a liter. Compared to the overall cost, it's not a big deal. And then, of course, the other fact is that this is located at 62 degrees north, which means there's very little sun in the winter. In terms of guest comfort, they've got a full commercial kitchen. They have a professional chef. They've got a hot tub. When they first put the hot tub in, it was running off electricity. There's a nice story there about warranty periods and getting it finally converted over to running off the diesel boiler, which they have for space heating there. They have a high efficiency diesel boiler that does their hydronic space heating, so they've put a heat exchanger in. Now they just run the pumps off electricity. It's still a big load. When the hot tub turns on in the evening, when the guests get back, it about doubles their electrical load in the lodge. They have pellet stoves now in some of the guest cabins, which is also a continual draw. They have to do water pumping. They have circulation pumps for their hydronic system. And as the lodge has grown over time, they've also added more and more freezers, which I find incredibly ironic because, of course, during the winter there, it's often -20, -30, and I'm not sure why they have to have as many freezers as they do. Having talked to them most recently, they are trying to use the natural cold to preserve their food, and during the summer, of course, they do need to run the freezers, but during the winter now they've got outdoor storage where they put their food, and of course it has to be secure from animals. So in the end, when I was approached by them, we had to come up with a plan to finance the project and how we were going to actually get the project built. And it actually became quite complicated, partly because of the way the financing worked. So right off the bat, I had to provide an analysis of what the payback on such a system was going to be. And at $3 a liter, it worked out to about 3.5 years payback. Depending on what realistic scenarios you wanted to run. I think the graph there shows about a 2-year payback, but overall, because of the rebates that are available, they're looking at about a 3 to 3.5 year payback on this system, just purely based on their diesel fuel consumption. So one of the sources of funding for this project is the Alternative Energy Technologies Program of the Northwest Territories. Delivery of the program for residential and commercial projects is through the Arctic Energy Alliance now. And we missed a cutoff date. Well, it wasn't an official cutoff date, but we were waiting with bated breath as they revamped the program, and we were hoping that our application got in time before they changed the rules. Unfortunately, it didn't. But they have a program where they're paying up to a third of the purchase cost of a system, and for a commercial project or a business, it's $15,000 per year. So they're going to reapply this year for more work to be done, but they had a grant for $15,000, and so my budget for materials and transportation was $45,000. The fine print was what came in under the revamped program was that they took installation cost out of the eligible costs for the program, which was a real blow because for a project like this, installation and transportation of the labor actually accounts for a fairly significant chunk of the project. So of that $45,000 project, originally we had budgeted about $10,000 or more for transportation, accommodation, and time for the labor. So we had to move that out of the project. It meant we could buy more materials, but we had to look for an alternative source of funding of that project. Just as an aside, residential systems get up to $5,000 per year, and in Yellowknife, since people are paying about 33 cents a kilowatt hour, there's a huge incentive to do grid tie systems in Yellowknife. Not only do you get a third of your purchase price removed from the cost, you're getting you can do net metering up there and get almost 33 cents a kilowatt hour. Certainly when you're offsetting your consumption, you're offsetting 33 cent kilowatt hour electricity. And just to put that in perspective, due to the clear weather that they get out there during a great deal of the year, as opposed to where I live, they get just slightly less, about 10 to 15% less sunshine than where I live in Courtenay, BC. So on an annual basis, their peak sun hours are very similar to where I live, and yet their electricity costs are about 3 times as high. So their payback on their systems in these locations is 10 years or less. So what we ended up doing was contriving a very complicated design, procure, build procedure. Viridian Energy Cooperative, which I'm a member of, which is a workers' cooperative on Vancouver Island, ended up providing the design and procurement of the materials. And then for the actual installation, since that was covered under a different grant, Deshinta Bush University took the lead, and that's an organization that provides training to Aboriginal people in leadership. It's an accredited program through Athabasca University, so they provide community sustainability, education, leadership training, and a variety of other things. And so as part of the community sustainability, Reid Wylde Engineering, my company, was hired to deliver that training as a workshop on the installation of a solar electric system. And they had grant funding to do that. So we looked at a different pot of money there. And then, of course, we needed to do the electrical work, so I subcontracted Optimus Electric, which is a local company that's affiliated with Viridian Energy, and so that's how we put it all together. So the design and procurement came from down south, as did the actual installation labor, although we had a number of students from the program assisting us on the installation. So you can see in the picture one of the airplanes flying in with our equipment, and then you can see Sam Piefinch in the bottom left-hand corner there smiling at the camera as we work on the power control equipment in the system. And then we also had assistance from the heavy-duty mechanic who is responsible for a lot of the maintenance and operations at the lodge there. And he provided a considerable number of man-hours to the project, which was donated by the lodge to the project. Getting to the real-world aspects of working up there, there's a laser pointer on here. There we go. So, of course, you want to do a site assessment, and we had you can see the orientation of this ground mount array as this post here lying underneath here. And one of the real-world aspects of this is that I wanted to put the array up near the lodge, up in the sunshine. And the owner of the lodge looked at where I was standing and said, no, that's not going to work. How high is this array going to be? And we're looking at modules that are about 6 feet tall. And he said, no, no. The guests like to sit and eat breakfast and look at the bay. You're going to have to move the array. Okay. So I'm already making changes to the system, and we're already at the point where we want to start doing preliminary groundwork. So I moved down the hill. No, still not good enough. So then I move over to the, I guess I'm moving to the west, into the trees. So you can see now, you can see the trees that are going to be shading the array now in the afternoon, in addition to the shading that we get sort of any time in the winter just because the sun is so low in the sky. So eventually we've ended up shoving the array over into these trees here, and that's where the client wanted the solar array, not necessarily where I wanted the solar array. Fortunately, when I did say you're going to have to cut down these 5 trees, he said, no problem, we'll use them for firewood. But it is one of the real-world challenges of working anyways with a lodge like this and with clients. You can also see some of the students here working on the installation of the array. This is what the ground mount array that we put in. Now the other challenge that we faced in the design is the high latitude, and you can see here in the wintertime the sun doesn't even make it over 5 degrees above the horizon on the solstice. We're not above the Arctic Circle, but it was kind of funny when I sent a message to my mom while I was up there working, and I said, I'm going out for a ski now, and this was at 2 in the afternoon. I want to get done before it's dark. Because by 3 o'clock, it's essentially dark, and this was in early December. And it never really feels like it's light out. It just feels like it's dusk the whole time. Of course, in the summer, we have this huge amount of sunshine from 3 o'clock in the morning till 10 o'clock at night. It never gets dark at night. When I first did the installation up there of the battery inverter system in the summer, the electrician I was working with went out fishing in the evening. He came back at about 4 in the morning. He hadn't realized that he just kind of lost track of the time. It never got dark. So it's really fun working up there. It's a very different type of place. Anyway, so I went back up there as part of the site survey. We had some preliminary design established, so we started doing the site prep. We got all the mounting on the roof put in, and we got the ground mount set up. I ended up modifying the ground mount once I was there because I was not in the same location I had intended to, and it turned out that they had a bunch of free wood that they'd obtained, which meant that I wasn't going to have to fly in a bunch of steel that I'd originally intended to use for the mounting structure. So we modified the design and built a wooden base for the mounting structure. And then a few weeks later, I came back, and I was constrained in terms of when the installation was going to occur due to when the course was running up there for Deshinta Bush University. And so you can see a picture of the students now installing the ground mount array, and my electrician again working on the power conditioning equipment, the charge controllers. So in the end, we now have with a new battery bank and the solar array in the winter, we're essentially running off the generator still. We're only getting, so this was a picture that I took around the 16th of December. We're still getting very short days, but even with that, now that we have the better battery storage, we're running the generator for about 8 hours per day, and that's with guests in the lodge, as opposed to the 24 hours a day they essentially had to run beforehand. So there's considerable savings there. Once the sun picks up into the summer, which is really their busy season, we anticipate they'll be able to run for days or possibly even a week and a half or so at a time without firing up the generator, because the array is sufficiently large to meet all of their electricity demands. They're also working very hard now to reduce their energy consumption so that they can reduce their diesel fuel consumption now that they're no longer dependent on the diesel. And then because I am an engineer and this is part of what I do, I put up a technical drawing for those of you that are interested. So we have the loads at the main lodge, which I mentioned already. We have the cabins with their pellet stoves and lights. We have staff accommodation, which is mostly lights and laptop computers. We have a 12 kilowatt diesel genset. They also have a 20 kilowatt that they use as a backup. We put in 7.2 kilowatts of solar arrays. There's 4 arrays. So the existing array was the 6 185 watt modules, and we used the existing charge controller. We just remounted those solar modules so that we had more room on the roof to put the rest of the modules up. We put in 2 new arrays on the roof. Because of the constraints of the roof, we had to limit those to 2 strings of 6 modules, running nominally 150 volt charge controllers. But because of the low temperatures there, we're certainly not running the arrays at 150 volts. And then we had the ground mount array, and we were able to go to a 600 volt charge controller for the ground mount because it's about 150 feet from the lodge. And with the 600 volt charge controller, we only had to run number 10 back to the lodge, which was a considerable savings. The storage now is about almost 4 times what they had before. We've got about 120 kilowatt hours of flooded lead acid batteries. We've got 2 4 kilowatt inverters, and then as I mentioned, we've got the 3 60 amp 150 volt charge controllers and 1 80 amp 600 volt charge controller. So this is what it looks like installed. Pictures obviously taken at different times of the year. You can see the older modules in the back. Because they were shorter and I was able to put them there at a high tilt angle, they don't actually block sunlight going in through the clustery windows, which you can see just behind there. So they're tilted up and they receive good sunlight in the winter. The other 2 rows, the middle row doesn't receive good sunlight in the winter. I had to accept some inter-row shading. You can see the shadows actually already on the array there. And that's because that photo was taken in late November, early in the morning. And there wasn't much I could do about that. Another challenge I faced was that originally all I had was the word of the lodge manager as to what the roof slope was. And when I got there and finally got the drawings in my hands, I discovered it wasn't a 412 pitch, it was a 3.25 12 pitch, which I'd never heard of before. Anyway, so there's a good reason for that that has to do with maintaining head height in some of the guest rooms, but it threw my inter-row shading calculations out the window, and I just had to live with it at that point. The front row does really well. It gets full sunlight all year round, and so I'm tempted to tilt it up to an even higher tilt angle to optimize in the winter, but for now we're just leaving things the way they are. And then finally, here's a picture of the power conversion equipment, all buckled up and tidied up. And as we speak, I think they're still running off the system. I haven't had any word back from them. This is Schneider Electric's XW system, and it has a comm box on it. So I'm actually able to log in remotely to this system from Courtney, and I can adjust settings on the automatic gen start. I can adjust settings on all the charge controllers and the inverters, and that type of thing. And I can monitor the system and see how the system is performing remotely as part of that, because they do have satellite internet to the lodge, so I'm able to log in remotely through their router. The biggest headache of this project is the rock. There's virtually no dirt there. And so of that 150 feet of tech that we ran back from the ground mount array, probably 2/3 of it was running over bare rock. And we had to, I talked to the inspector about it, and he wanted us to cover it in concrete over that entire distance because, of course, people run skidoos through there in the winter, and he was concerned about the treads chewing up the cables, which is understandable. So that was the biggest headache, was getting that installed and buried and safely done. On the other hand, one of the best parts was working with Deshinta Bush University on this project. One of the students actually came up afterwards and said, you know what, I want to be an electrician when I finish this program, which was quite rewarding. And then, of course, it's just a beautiful place to be. I'm not sure, we don't have internet access here, but that's actually a clip from a video from one of the guests that he made of the Aurora Borealis, which I was able to witness. The last night I was there, I woke up at about 6 in the morning. There were shooting stars. There was the Aurora Borealis, and I was just looking right out the lodge window up at the northern sky and staying nice and snug and warm in my bed in the lodge. And I should also mention the sauna. They have a nice wood-fired sauna there as well, which is quite enjoyable. You can go out and roll in the snow afterwards. Future plans for the lodge. They would like to put up another wind turbine. The original wind turbine, the cable snapped, and that was just due to rubbing of the cable against the anchor points on the ground. You know, it's one of the reasons why I find wind to be so frustrating is that there is maintenance involved in wind turbines and regular inspections, and all the manufacturers pretend there isn't. But they would like to put up another wind turbine. So I'm hoping to go back up there late April, early May, put up a wind turbine for them. And ultimately, we hope to replace the batteries for them down the road with the more modern lithium-ion batteries when they become more readily available and compatible with the inverters that we have up there. And anyways, they're set to, ultimately they'd like to be 100% renewable energy, which may be difficult in the winter. They'll need more wind turbines to do that, but they're getting very close to their goal. What we project right now is 75 to 80% renewable energy now for that lodge over the course of the year. And that was my fun project up in the north. I've also worked on other projects up there. I worked at Aurora College up in Inuvik. They had an off-grid system up there and the batteries froze one winter. So I went up and I did the first grid tie system in Inuvik for Aurora College. Some of you might know the sun tie inverter. Not the best inverter in the world, but it was what was available. So we put a sun tie inverter in the system up there. And it was really kind of funny doing a grid tie system because the local representative for the power authority came over and he said, well, we've never done one of these. What do we have to do? So I downloaded the BC Hydro net metering application. We whited out the BC Hydro logo and we put their logo on it. And I signed it and he signed it and we had a grid tie system. And a lot of the stuff up there is like that. I should also mention, don't send anything up there FedEx. It could take 5 to 10 days for something to arrive when it's supposed to arrive overnight. The best way to send something up there actually is Canada Post. It's way more reliable. We had a lot of logistics issues, and of course Gordon knows one of the logistics issues which he was incredibly good at dealing with was I got up there, I did a parts count, and I discovered I was missing 2 end clamps for the ground mount array, which would have meant going back up there because we wouldn't have been able to complete that array. So Gordon contacted the supplier and the manufacturer, I guess, too. They were couriered up to Edmonton. He drove to the airport, put them on the plane. They arrived. They got on the plane from Yellowknife the day after, arrived at the lodge in time for us to complete the installation. And so he saved our butts on that one. Thank you very much.
So how many people here have been in the Arctic at all? Yukon, Northwest Territories, Nunavut? A few people? What do you like about it up there? Wylde, yeah? Any others? Whenever I'm in the Yukon, I always like to ask somebody, anybody, how did you come to be up here? And invariably they'll say to me, well, I came up here 20 years ago for a summer job and I fell in love with the country and I just could not leave. And I understand that. It's really quite amazing. I've been up there in the summer and also in the winter when it's really dark, and it's just a really special place. So, as Warren said, I am a professional engineer. I've been working in the solar energy industry since '76 and in the solar electric industry since '83. We design, develop, supply, and commission solar electric systems for any reason. We don't have any vested interest in any one particular solar technology. We just want you to make your decisions with your eyes wide open and decide what is best for you. Tonight, gosh, this is going to be way too brief. I'd prefer to speak for an hour and a half rather than half an hour. But I'm just going to present a very brief discussion on 6 projects, 3 grid connected, 3 off grid. I'll talk a bit about the logistics and about the costs and economics. So the first one, the first 2 projects are in Old Crow. Has anybody heard of Old Crow in the Yukon? Very top part of the Yukon. It's latitude 67.5 degrees, so 2,100 clicks from Edmonton, 112 clicks south of the north of the Arctic Circle. So it does get 24-hour dark in the winter for 12 days, and 24-hour light for 49 days in the summer. And I'm not sure why those aren't both 12 or both 49, but that's what the sunrise sunset time said. It's Yukon's only fly-in community. Most of the time you have to drive a fly there, but every 6 years or so they will put in a winter road, and so they'll bring in school buses and graders and other heavy machinery that'll stay there for 50 years. And otherwise it's only fly-in. And their temperatures go from plus 33 down to minus 59. So, you know, it's an interesting place. So here's a picture. I've been there twice. Here's a picture of the community as you fly into it. It's right on the banks of the Porcupine River. You see the airport. It runs alongside the whole community, and you can't see it, but there's a solar PV system on this building right here, and that's what we're going to look at. 245 people live there. Most of them are from the Vuntut-Gwitchin First Nation, and 162 houses. It's very rugged up there. Very rugged. I mean, I could give you an hour presentation on all the pictures I took, but just a little panorama right in front of the main street. This is the kind of scenery from looking at the Porcupine River. This is due south. October 21st, it was minus 25. Everybody was saying how nice and autumn it was. It wasn't winter, it was autumn. And they were out building houses and scootooing around, and there was even one chap there who had shorts on, literally shorts. Yeah, the sun was out. The river wasn't frozen yet, and they encouraged me to grab a fishing pole next to the river and go out and grab some fish. Okay. So this is the main road off to the left there. This is one of the systems we'll be looking at. I'm just standing in a circle and taking pictures on the sequence here. And here's the other building we'll look at. So it is an electricity, it is a diesel grid as it's called. There are 3 diesel generators, 170, 330, and 600 kilowatts, that are turned on and off as a function of how the load goes up and down. And they back up each other, so they are, when one fails, they do have the others as backups. And they have, at this time, around a 500 kilowatt max load in December. The first system was on the Vuntut National Park Information and Operations Center. So it's a 3.3 kilowatt grid-dependent solar electric system, just like you'd find here. No difference at all. We installed it in 2008. And you'll notice the building there is on stilts. Do you know why? Sorry? No, not snow. Permafrost. They don't want the buildings to melt the permafrost. Not good if you melt permafrost. So they make sure that the underneath the building stays frozen all winter long, so it doesn't get melted. This was designed by an architectural company called Kobayashi Architects in Whitehorse, and you'll see that they have this interesting sequence down the south side where they have solar modules at some points and this plastic glazing at other points. And over here, there's double high windows, so the plastic glazing allows the light to come through the windows, just for aesthetic reasons. But because of this, the architect chose a certain size module, solar module, for this, but that module was obsolete. And there was a company in Inuvik that was contracted to build the building, and then they phoned me out of the blue and told me and hired me to design and supply the solar electric system. So here is a close-up of the solar modules. They wanted BP solar 80-watt modules, but we couldn't find any because they weren't made anymore. But we found 75-watt modules, and that were roughly the same size because they wanted them to match this. It's not plastic glazing. It's polycarbonate. Yes. This polycarbonate glazing right there. So there's the solar module. So how many solar modules do you see here? 9. How many solar panels do you see here? 3. Because this is a really good explanation of the difference between a solar module and a solar panel. A solar panel is a number of solar modules mounted together on a rack. And there happen to be 3 racks supporting this there. So there are 3 solar modules, solar panels. So in the whole system, there's 45 modules, 15 panels, 3 strings. A string is a number of modules electrically connected in series, 1 array at a 75-degree tilt, which is fine. The optimum for Old Crow is 70 degrees, but if you include snow reflection, it's probably 75-ish. There's 1 Sunny Boy 4-kilowatt inverter that converts a couple hundred volts into 240 AC for the building, just a standard inverter. We expect it to generate roughly 3,225 kilowatt hours of electric energy per year, 268 per month, which is just 22% less than Edmonton. So it's not that the Arctic is dark, sure, in the winter, but then Edmonton's dark. Did you realize the whole world is dark half the time, no matter where you live? It's just that in the Arctic it's a bit concentrated in the winter. This 3,225 kilowatt hours is worth $1,900 a year. Can you imagine putting up a 4-kilowatt array and generating $1,900 a year worth of electricity in Edmonton? That's 5 times more than it would be worth in Edmonton. Why? Because the price of electricity in Old Crow is 60 cents a kilowatt hour, 5 times what it is in Edmonton. And it'll reduce emissions from the diesel generators by almost 3 tons per year. Now, what the cost and the economics of the project are, I don't know, because all I did was design and supplied the equipment to Weitzel's Construction in Inuvik, and then they installed it, and I don't know what that price was. It's a bit too bad. Here's what the expected energy performance looks like. The blue line is the energy generation, and you can see it's really good, except for 4 months of the year. So sure, December there's sweet tweet because they have the few days of darkness, but there is something the rest of the year. And then the yellow dots are the solar radiation. So you see how well the solar generation follows the solar radiation, as it should, of course. And this is at a 75-degree tilt. So they get about 3.2 sun hours per day of solar radiation on a 75-degree tilt throughout the year. In contrast, Edmonton is at 4.3, I think it is, on a 75-degree tilt. So of course we're more, but we're not a huge amount more. The logistics of the project were really quite interesting. This was the first time I'd ever done a solar electric system up in the Arctic. The building was designed before the PV system was designed, and that always causes a lot of issues. Because really, if you're going to integrate the solar system into the building, you really should be able to talk to the architect and the structural engineers to have them make better decisions so that issues don't arise. We are thankful that I did find a 75-watt module, but if I hadn't been able to find it, the architect's plans for this would have had to be redone because things were changing and he hadn't realized it. The electrical room was absolutely packed full of equipment. Luckily, we only had one little inverter to put in, as you can see, but it was interesting to see whether there could be any room for the inverter, actually. I mentioned that the architect had picked a certain module because of how it fitted into the building's awnings. And the equipment was shipped from, by truck from here to Inuvik, and then it was flown in on Twin Otter from Inuvik to, in the Northwest Territories, into Old Crow. There's more stories I could tell about that, but not in public. The building contractor was really interesting to work with. He had never done a PV system before, which is fine. I'm happy to work with people who haven't had experience. But he was disparaging of solar's value. It was just crazy trying to get him to understand the cost effectiveness, et cetera, et cetera. He was from Vancouver, so he flew in and out from Vancouver, and he just didn't care about this. Then he made some installation errors, actually went against my drawings. And then he went out of business. So the errors are still there, unfortunately. The challenges were very interesting because I was working at a distance from the site, and I had never seen the site. I'd never been to Old Crow. I just went to Old Crow after it was all done and checked all his work and commissioned it and turned it on. The PV module wasn't manufactured anymore, so I had to find another module that would fit, as I mentioned, fit the architect's dimensions and fit with the inverter. And then I was working with the electrical contractor that was not experienced, and we didn't know whether the equipment could really fit in. And then we were working through grid connection relationships with ATCO in the Yukon when there was no territorial grid connection policy. Now, I'm thankful that I had a good relationship with them up there, and so it didn't present an ultimate stop to the project, but I did have to encourage them and let them know how things worked. And thank goodness for our experience here in Alberta so that we can help use that to help other jurisdictions open up to the grid. And now up in the Yukon, they do have a grid connection policy, so that's working well. And then communication from here to the site was more or less impossible. There doesn't seem to be any, at that time, there wasn't any cell phone service in Old Crow, and so I couldn't talk to the guy while he was doing something on site. He had to go back to wherever he was staying. And in Old Crow, there's two bed and breakfasts to stay at, and that's it. And they're usually chock full all the time. So finding a place to stay up there is difficult. The second project in Old Crow is the Arctic Research Facility. Effectively, it's just a 4-bay garage for a paleontological group, a university, national parks, and I think the Vuntut-Gwitchin First Nation. And you can see little ramps there, and it's right next to the river because they keep quads and Zodiacs and snowmobiles in the garage. And then on the left end, there's a place where they store dinosaur fossils and mammoth fossils when they find them. So it's got 11, almost a 12 kilowatt grid-dependent solar electric system. And it was installed in 2010. And again, I supplied it and somebody else installed it. It was designed by the architect to go on these 11 towers. So he wanted 55 solar modules on 11 towers. 55 is not really a good number for a solar system because usually you need even numbers divisible by all sorts of other factors in order to match the solar modules with the inverters. And so I had to play around with all sorts of combinations in order to get 55 solar modules to work with the inverters. It was really quite interesting. And then you can see that underneath the building is still on stilts. So the electricity comes down from the towers, goes underneath the building, across to where the electrical room is, and then up into the room. Here's a bit of a close-up. They were Sanyo HIT modules, 215 watts each. This was, again, 2010. The prices were starting to come down on these. They are high-efficiency 75-watt modules. Does anybody know what the warranty is for solar modules? What temperature are they rated to? -40. And what temperature does Inuvik get to? 59. So what do? Has anybody ever seen a solar module rated below -40? So what do? And the architect wanted a warranty. So what do? Why worry about it? Yeah, well, a warranty is a piece of paper. So I was very pleased that my supplier, Conergy, which has now been bought out by HES, Home Energy Solutions, they wrote me a warranty. They said, sure, we'll cover it. Fine. So there's a solar module, and you'll never guess what the solar panel is. The tower. Of course, because that's the rack. The 55 modules, 15 panels, 7 strings, 1 array, 90-degree tilt. Again, the optimum is 70. What's fascinating also is that there's some shading there, because the railing will shade the lower solar modules at certain times of the day. So I had to take that into consideration too as I was setting up the strings. And so I sacrificed one of the inverters and tried to put as few modules on that string so that it would have as least interference as possible from the railing there. And there were about 5 modules that had this shading from the railing. I made it fit into 3 inverters, 2 5 kilowatts and a 3 kilowatt, that generate 240 volts. The whole town is on 240 volts, not 208 or anything like that, because there's nothing really big in the town. I expected to generate 9,500 kilowatt hours per year, 29% less than in Edmonton, because it's at a vertical tilt, with $5,600 a year, because it's 60 cents a kilowatt hour electricity. Reduces by 8 tons a year, and I don't know the economics because, again, somebody else installed it on a different budget.